Alright, so here we have a problem here. So we are told that transformation T, represented by the matrix 2, negative 1, 2, 0. We normally call out the rows first, right? So 2, negative 1, 2, 0. Maps the point 1, 5, P1, 5 to P prime AB. So yes, so sometimes we use matrix or matrices to represent transformations. Good, so the matrix T maps 1, 5 to AB. What do we mean by maps 1, 5 to AB? It means that when you multiply the matrix 2 minus 1, 2, 0 to the point 1, 5, it gives you the point AB. Alright, so this matrix, it maps 1, 5 to a particular point. So we're asked to find that point. Alright, just watch the language they use, maps the point 1, 5. It just means that when you multiply it by 1, 5, you get the image point. So this point, this matrices, this matrix, sorry, that this transformation it's representing a transformation, maps 1, 5 to that. So you map 1, 5 to that, mean you multiply it by 1, 5. Let's see what happens now. So the multiplication. So you multiply. So 2 times 1, that's 2. Plus minus 1 times 5, that's minus 5, right? And then 2, 0 times 1, 5. So 2 times 1, that's 1. 2 times 1, that's 2, sorry. Plus 0 times 5, that's 0. And 2 take away 5, that's minus 3. And 2 plus 1, that's 2. So in other words, this transformation represented by the matrix T maps 1, 5 onto negative 3, 2. So the point P prime is negative 3, 2. So P prime is negative 3, 2. Now, we're asked to determine AB, which we just did. Alright, we just did A is minus 3, right? And B is 2. So A is the x coordinate, B is the y coordinate. Now we're asked to also find the transformation that will map back P prime to P. So this transformation T, it maps 1, 5 to negative 3, 2. So we want the transformation that does the opposite. We want the matrix that does the opposite to what T does. And what do you think is that? The same idea as functions, that would be the opposite matrix, or we call it the inverse matrix, right? So if a matrix maps 1, 5 to a point, then the inverse matrix will map that image point back to the original point. So let's find T inverse then, because that's the matrix that does that. So T inverse, and we have a formula for inverse of a matrix, 1 over determinant. Now here's T. Here's T. What's the determinant of T? Determinant of T, 0 times 2, which is 0. Take away 2 times minus 1. What's 2 times minus 1? That's minus 2, right? So the determinant is 2. Double negative gives us a positive. So 1 over 2. Right, determinant is 2. Times the adjoint of T. Now here's T. What's the adjoint of T now? So these elements switch places. So 0 come here, so. And 2 come down there, so. And then these elements in the other diagonal, they change the sign. So negative 1 becomes positive, and positive 2 becomes negative. Alright? So we are claiming that now, this transformation T, or this matrix T, will map back. I remember what AB was. AB was minus 3, 2. So we're saying that. So the original T, you multiply it by 1, 5, you get negative 3, 2. So the inverse will do the opposite. The inverse, if you multiply the inverse by negative 3, 2, you expect to get 1, 5. Let us try it, just to test if we have the correct transformation. Okay, so I clear the board to make some space. Alright. Let's multiply each term here by half, just to Let's multiply each term by half quickly. So to get t. So half times 0, that's 0. Half times 1, that's 0.5. Half times minus 2, that's minus 1. 0.5, right? And half times 2, that's 1. That's my t. That's my t inverse. Alright? And so we believe now if we multiply the t inverse by negative 3, 2, let's multiply it by negative 3, 2 now. So 0 minus 1, 0.5, 1. That's what t inverse is. And let's multiply it by negative 3, 2 and see what we get. Alright, see what we get. So remember, row by column, right? Row by column. So 0 times minus 3 give us 0. And then 0.5 times 2, that's 1, right? So 0 plus 1, that's 1. Here now, we have negative 1, 1 times negative 3, 2. So negative 1 times negative 3, that's positive 3, right? Plus 1 times 2, that's 2. So we end up with 1, 5. Good? We're not with 1, 5. Alright? So I want you to get this concept. Alright, very important. So, T maps negative 3 to, T is the original matrix. It maps 1, 5 to negative 3, 2. Meaning, if you multiply this matrix by 1, 5, you're going to get negative 3, 2. Now, we were asked to find a matrix that will map back the P prime, this prime, negative 3, 2 to 1, 5. So, whatever matrix brought 1, 5 to negative 3, 2, the inverse or the opposite of that matrix will do the opposite thing. Will map back negative 3, 2 to 1, 5. And that's why we find the inverse of T, because whatever T does, then T inverse will do the opposite of that.